Morning, people. I hope you're doing well, my lovelies, so let's get into it. Where it, of course, may contain science. And a healthy dose of here we go again. I've repeatedly invoked the Venusian phosphine story in all sorts of circumstances. How scientific findings depend on the particulars of data analysis, how retractions and revisions happen in published literature, how it's just really freaking hard to figure out anything about Venus. So, it sure would be a hell of a thing if we got right back into phosphorus-related mess with a different body in our solar system, wouldn't it? In related news, let's talk about Enceladus, and how it got its life ingredients in it. But more on that in a moment. Enceladus is the 6th largest moon of Saturn, and it is much, much larger than our moon, but much, much smaller than Earth. It's a rocky ice moon with cryovolcanic activity that causes huge geysers. And if that's ringing a bell, it's because our adopted stream child, the James Webb Telescope, has taken a look, and those geysers are rather large. Of course, by rather large, I mean the height of this geyser is 19 times the entire diameter of Enceladus itself. Like, at that point, that's a geyser with a moon attached. This all is consistent with Cassini's observations throughout about a 20-year period, and about 1/3 of Enceladus's water molecules from these geysers become a ring for Enceladus. Saturn's moons even have little rings, just like the adults. The rest of the water either joins Saturn's own icy, rocky ring or gets into the atmosphere of Saturn and the other local moons. So the story here isn't that Enceladus has these geysers, but that our telescope baby got a look at them with all the modern technology she's got packed on board. And you'd be right for wondering, Sam, you didn't cover this story back when it came out in May. Why are we talking about this now? Was there a shortage of science and this was the only story you could find? To that, I say absolutely not. We only serve fresh science here. And also plenty of you heard that story, so you didn't need me to tell you about it. No. I'm mentioning Enceladus's geysers because we know how telescope science works. First, you gather the data whenever you can get time in the telescope, which is itself more competitive than nerds at a Star Wars trivia night. And then, once you've got loads of raw data, you analyze the ever-living crap out of it. So, the thing is, today's science isn't actually related to our stream baby's observations recently at all. Astronomers are going to need time with those findings. These findings in Nature Astronomy uses data from Cassini's Cosmic Dust Analyzer. You know, the mission that ran from 2004 to 2017? Look, I gotta hand it to these authors. They struck while the Saturnal lunar geyser was hot. And they got their findings published in a high-profile journal as a result. Cassini was absolutely stacked with sensors, because if you're gonna undertake a 7-year mission just to get to your location, you better make it worth it. And the Cosmic Dust Analyzer itself is a multi-sensor instrument with a time-of-flight mass spectrometer, an impact ionization detector, and 2 high-rate polarized polyvinylidene fluoride detectors. No, they're not trying to detect polyvinylidene fluoride. It would be really wild if Enceladus just randomly had thermoplastics in its atmosphere or something. The detector is a polarized film coated in polyvinylidene fluoride, and it produces a special charge when impacted by high-velocity dust particles. Not at all the point of this week's science, but it was a question I had when I was reading about this, so I wanted to share the answer with you too, my lovelies. No, the polyvinylidene fluoride detector isn't the key instrument here. It's actually the mass spectrometer, because our study's authors used data from that instrument to confirm that Enceladus's big geyser, now caught in glorious James Webb Space Telescope 4K, may not only contain science, it contains phosphates. Sam, you can't do this to me. I've been hurt before. No. This isn't Venus all over again, I promise. There is a huge distinction between the phosphates discovered in Enceladus' water geyser, and the phosphine from that ill-fated Venusian finding. Phosphine occurs in inorganic reactions, and those reactions seem to happen on Venus more often than Team Phosphine had thought, as we discussed recently with our Venusian volcanism. But phosphine is also a byproduct of organic reactions, and that's the difference here. Venusian phosphine data suggested there might be actual life already on Venus. The phosphates on Enceladus, however, are about the ingredients of life. Indeed, as we covered last week, phosphates are key to the whole life needs things to live as we know it. DNA, RNA, ATP, phospholipids, the building blocks we use on this planet, have got phosphates involved. So, once you get to biochemistry beyond amino acids that can be created inside nebulas but aren't themselves part of life stuff, life as we know it uses phosphates to build bigger structures. Heck, phosphates are so important that last week's featured plant, T. peltatum, turns carnivorous when it craves phosphates. The team that made this discovery analyzed 345 particles and identified 9 with spectral features unique to sodium phosphate. They also replicated the spectral signature by firing a laser at sodium orthophosphate and disodium hydrogen phosphate dissolved in water, which reproduced the chemical signature observed from Enceladus' geyser. That's not fuzzy math and circumstantial evidence. We can be pretty confident that Enceladus has got sodium and phosphorus, and in no small amount. Our researchers hypothesize that this is a product of alkaline, the water in Enceladus' subsurface ocean, and its core rock. If Enceladus' rocky core is indeed made of carbonaceous chondrite, as many suspect with the silica nanoparticles Cassini has previously observed, chemical interactions with that core would absolutely produce the phosphorus our team found. Previous evidence has already confirmed Enceladus has carbon, hydrogen, nitrogen, and oxygen. I mean, some of those are kind of gimmies with the whole water thing, but still. Phosphorus is the 5th of the 6 critical life ingredients, and tentative evidence does suggest the 6th, sulfur, is also present based on emissions data. Enceladus has got all the essential elements of a complete breakfast, where breakfast in this metaphor is ingredients for life. That means Enceladus may well be technically habitable, where technically is perhaps the worst kind of habitable. Now, the question sci-fi fans salivate over: if it's habitable, is it inhabited? We have absolutely zero evidence to that effect. I mean, I've got the ingredients for a delicious meal in my house, but I'm rubbish at cooking, so the existence of ingredients in no way implies the existence of the meal. Cassini had incredible instrumentation, as does our baby, the James Webb Space Telescope, but neither was equipped to discern the existence of life in a subsurface ocean on the moon of Saturn. We have a hard enough time finding life forms at the bottom of our own ocean, and we literally live here. But we've got evidence of liquid oceans, high-temperature water-rock interactions, and hydrothermal environments, and now pretty much all the things life needs to live. So, you better bet astronomers are going to want to go and take a look under the hood to find out for sure, and they are going to pester their funding organizations like botanists begging NASA for moon dirt to grow plants in. There may have been single-celled organisms millions of years ago, but not now. There may be life millions of years from now, but not yet. Heck, there may not be life there right now, but we accidentally transport some bacteria and Enceladus ends up with life in it. Not the most likely, sure, but we're surprisingly bad at avoiding space-based contamination. But honestly, I've always liked the gas giant moons as candidates for interesting stuff, chemically speaking, and I'm sure we'd put a lot more focus on investigating them if Enceladus weren't like 1 billion kilometers from Earth. The hope, then, is that a finding like this, especially while Enceladus science is so hot in the public imagination, might inspire funding organizations to throw their weight behind further exploration of a place that's technically habitable. I will not, for the record, be inhabiting it. I'm from Southern California. I need my sun.